Good afternoon. My name is Trevor Lemaster. I'm here representing Sterling Energy. Our team comprised of myself, Andrew Kayota, as well as Nicholas Bedard. Here I'm going to be giving you a presentation on the project that you have assigned to us, which was to develop a product for the college-age market in which we see a gap in the market for. And so with this presentation, I'm going to be giving you an update on where our team is at, how our product is doing, and just to give you a little bit of background of what our product is. Our product is a desktop Sterling engine. And so when we looked at the college-age market, when we did our customer interviews, we found that there was a lack in college-age toys. And so what we found was that this desktop Sterling engine would be the best product to fill that gap. And so when we looked at our customer interviews, we came up with, from those, we came up with customer needs that were later translated into customer specifications. So specifications that our engine needs to have in order to be successful and appeal to the market in which we are appealing towards. In which, for this desktop Sterling engine, is for do-it-yourself hobbyists. It's for college-age students who have an interest in hot rodding or machining, or just how an engine works. And before we dive into the different components of the engine, we're going to be looking at the engine as a whole. We're going to be looking at the functional decomposition. So what goes into the product, and then what goes out of the product. And so for our desktop engine, you can see that heat energy is going in, as well as DC motor torque. So these inputs are likely going to be these are going to be what starts the engine, as well as what keeps the engine running over time. And so from that, our output is going to be output energy. So from this wheel here that is going to be spinning during the motor functioning, it's going to produce energy as a result. And we're going to translate that energy into a few different, we could do it into a few different ways that we'll later dive into. And then also output signal. So this is going to be how we can analyze the engine telemetry and different components such as the engine temperature, the engine RPM, and ways that we can do that. So now we're going to move into a phase, the team moved into a phase of concept generation. And this is where we looked at just the different components of our product, what functions that we wanted to accomplish, and how we can do that. So the first method that we did the 3-2-1 method. And what this was each member of the team came up with 2 full solutions to the product of the desktop Sterling engine. And so those comprised of different components. They accomplished different goals, but they were still the desktop Sterling engine. And so once each team member did 2 of those, we then passed the designs on to our teammates. We got critiques, we shared our likes and dislikes, and we also just got to see just the different places that our product could go. And so from this, after we did this, we moved on to a different method. We did the mind map. So the mind map was a way that we can look at the different functions, how they connect, and then what specific components we could be using to accomplish those functions. So functions such as starting the engine, collecting data from the engine, as well as providing energy to the engine. And so we looked at different components that we use to accomplish these goals. And so from that list, we moved on and we came up with 5 sub-functions for our product, for our desktop Sterling engine. And within each of those functions, we came up with 2 to 3 components that could be used to accomplish those functions. So for the sub-function, provide heat to energy, provide heat to the engine, we looked at a candle as a possible solution, an alcohol lamp, and butane. And from this, we came up with, from the 3-2-1 method as well as the mind map, we came up with 6 possible solutions. As you can see from these lines, each line represents a different solution. And the solutions are comprised of a different combination of these components that accomplish these sub-functions. And before we move forward in analyzing these different solutions and how they ranked against each other, we first wanted to get feedback from our peers and our classmates. So what we did as a team was we set up a poster in our class, and our peers came around and we got to explain our product. And they got to ask us questions about the product, what they liked and disliked, and it was really just very good feedback that we got. And so the main feedback that we got from this process was some concerns with the heating element of our product, of the desktop engine. And so the major concerns were that there was an open flame, that how to attain the fuel and how to contain the fuel. And these are under the category of safety. And obviously safety is a very important component of our product. We obviously want our product to be safe for consumers. Another concern that they had was the practicality of the output. So would we generate enough power for our phone charger? Would we be able to produce enough output for an LCD display screen? And so these were very good feedback that we got from our classmates, and we're going to keep them in mind as we move forward with our product. So then moving from there, we decided to go into the different sub-functions and the different components. So we moved on to the concept selection phase. The concept selection phase comprised of looking at the different solutions and how they ranked against each other. So here we have the different solutions across the top with the different components of them. And along the left side here, there are the different specifications or the criteria in which we're going to analyze the solutions. And so for each solution, we went through and compared it with another solution within that certain criteria. And from this process, we came up with 3 solutions that we wanted to move forward with. They are solution 1, solution 3, and solution 5. And from this, we decided that we actually were going to generate a hybrid solutions, 2 hybrid solutions that we found would be the best options, that we predict will be the best options. These are solutions that we comprised of the components that we felt would be the best for the product. And so after this initial screening, we went through and did the concept evaluation. So this was analyzing our different solutions here shown at the top, the different 5 solutions, and the different components as you can see here. And then what we did was we analyzed the specifications and the criteria again, except this time we gave each criteria a weight on how important it was to our goals and how important it was to our product. And for each solution, it was given a rating based on how it did in that criteria. So after this was all said and done, after we did the calculations, solution 5 posed to be the best solution. It's composed of the key switch, the DC starter motor, the candle, the LCD display, as well as the desk fan. And it should be noted that this solution, solution number 5, was our hybrid solution, one of the hybrid solutions that we came up with. So it is one of the ones that we predicted would be the best based on the components that it has. And just to give you a little visualization of what the product would look like, here we have our desktop engine, we have our candle, which will be used to provide the heat for the engine. We have our DC motor, which will actuate and initialize the spinning of the motor. And then we have our key switch, which we're going to be using to start the engine, and then a fan, which will be used as the output. So the output from the energy of the wheel will be translated into the fan, as well as the LCD display. And so moving forward, our team is on pace to continue with this product. We're going to move forward with the product development stage. And what this comprised of is prototyping, building the actual Stirling engine. And so in a few weeks, my fellow team member, Andrew Kayota, will be back to give you another update on how our team is doing, how our product is doing, and what process, where along the process are we in terms of finishing this product. Thank you very much, and I'll see you in a few weeks.